The neurobiology of aging presents a distinct choice between inevitable decline and sustained cognitive precision. Current scientific understanding suggests that the deterioration of memory systems is often less about the passage of time and more about the cumulative biological insults inflicted by specific dietary inputs. The modern environment saturates the daily routine with compounds that systematically dismantle the blood-brain barrier and disrupt synaptic signaling. By identifying and removing these neuroinflammatory agents, the brain can recover its metabolic stability and maintain high-functioning neural circuitry well into the later decades of life. This approach shifts the focus from managing symptoms to preserving the structural integrity of the nervous system itself. The metabolic impact of refined sugars and glycemic volatility, the relationship between glucose regulation and neural function, is foundational to understanding how memory preservation works. While the brain demands a significant portion of the body's energy, flooding the system with refined sugars creates a paradoxical state of starvation within the brain cells. Andrew Huberman often highlights that chronic exposure to high glycemic loads leads to insulin resistance not just in the body, but in the brain itself, a condition some researchers refer to as type 3 diabetes. When neurons become resistant to insulin, they lose the ability to efficiently absorb glucose, their primary fuel source. This metabolic failure forces neurons into a state of energy crisis, where they struggle to maintain the electrical potentials required for encoding new memories and retrieving old ones. The hippocampus, the brain's memory center, is particularly sensitive to this energy deficit and begins to atrophy when fuel access is chronically impaired. The biological mechanism driving this damage involves a process known as glycation, where excess sugar molecules bind to proteins and lipids, forming harmful compounds that stiffen tissues and disrupt cellular function. In the brain, these advanced glycation end products accumulate and interfere with the delicate machinery of synaptic transmission. It creates a noisy environment where the signal-to-noise ratio degrades, making it difficult for the individual to focus or retain information. The inflammation triggered by this process further compromises the blood-brain barrier, allowing toxins to enter the protected neural environment. This cascade of dysfunction is often invisible until significant cognitive lapses appear, but the damage begins with the very first spike in blood glucose that exceeds the body's regulatory capacity. Consider the common scenario of a breakfast built around sweet pastries, processed cereals, or sweetened coffee drinks. This intake causes a rapid surge in blood glucose, prompting a massive release of insulin to clear the sugar from the bloodstream. For a brief period, the individual feels a burst of energy, but this is quickly followed by a crash as blood sugar plummets below baseline. During this crash, the brain perceives a survival threat and releases stress hormones like cortisol and adrenaline to liberate stored energy. This stress response dampens the prefrontal cortex, the area responsible for planning and emotional regulation, leading to brain fog and irritability. Repeatedly subjecting the brain to these roller coaster shifts in energy availability wears down the resilience of neural networks over time. It is important to distinguish between processed sugars and the complex carbohydrates found in whole foods. Nature packages sugars with fiber, water, and micronutrients that slow absorption and blunt the insulin response, providing a steady stream of fuel rather than a damaging flood. The problem lies specifically with isolated sugars and refined flours that enter the bloodstream with the speed of an injection. The removal of fiber during processing strips away the protective mechanism that biology designed to regulate energy uptake. When the individual consumes whole fruit or starchy vegetables, the metabolic impact is fundamentally different and supports, rather than hinders, brain health. However, the complete elimination of all carbohydrates is not always the optimal strategy for everyone, as some neural functions rely on glucose availability. The critical distinction is the source and the velocity of delivery. It is perfectly reasonable to pause and acknowledge that dietary changes are difficult when sugar activates the same dopamine pathways as addictive substances. The objective is not rigid deprivation, but the stabilization of neurochemistry. By shifting the fuel source to slow-burning carbohydrates and healthy fats, the brain receives a consistent energy supply that supports the maintenance of dendritic spines, the tiny connections between neurons where memories are physically stored. This stability allows the brain to direct its resources toward repair and growth rather than constantly managing metabolic emergencies. The reduction of refined sugar intake also impacts the production of brain-derived neurotrophic factor, a protein essential for the survival of existing neurons and the growth of new ones. High sugar levels suppress the expression of this critical growth factor, effectively halting the brain's ability to adapt and rewire itself. Preserving neuroplasticity requires a chemical environment that fosters growth, and high circulating insulin is a direct antagonist to this process. The shift away from refined sugars acts as a signal to the body to prioritize maintenance and autophagy, the cellular cleanup process that removes damaged components. When the metabolic machinery of the brain is functioning without the interference of insulin resistance, cognitive endurance improves noticeably. The individual finds that mental fatigue sets in much later in the day, and the ability to recall names, dates, and complex concepts remains sharp. This is not merely about avoiding disease, but about optimizing the performance of the neural hardware. The brain is a high-performance engine that requires clean fuel. Putting refined sugar into this system is akin to pouring sand into the gears. The restoration of insulin sensitivity represents one of the most powerful levers for protecting cognitive longevity. Am I feeding my brain fuel that builds it up or fuel that breaks it down? The inflammatory cascade of industrial seed oils, the structural integrity of every neuron in the human brain depends heavily on the quality of the fats consumed in the diet. The brain is primarily composed of fat, and the lipid bilayer that forms the outer membrane of each cell dictates how well that cell functions. Andrew Huberman and other experts in neurobiology point out that the incorporation of industrial seed oils into the diet has fundamentally altered the composition of these cell membranes. These oils, often rich in omega-6 fatty acids, are prone to oxidation and drive systemic inflammation. When a diet is dominated by these unstable fats, they are incorporated into the neural membranes, rendering the cells less fluid and more susceptible to damage. This rigidity impairs the function of receptors and channels on the cell surface, slowing down the speed of communication between neurons. The mechanism of damage centers on the concept of lipid peroxidation. Industrial seed oils, such as soybean, corn, and canola oil, are highly unstable when exposed to heat, light, or oxygen. Inside the body, these oxidized fats trigger an immune response, releasing inflammatory cytokines that can cross the blood-brain barrier. Once inside the brain, these cytokines activate microglia, the brain's resident immune cells. While microglia are essential for cleaning up debris, chronic activation causes them to attack healthy synaptic connections. This process, known as synaptic pruning, is necessary during development but becomes destructive in adulthood when driven by inflammation. The result is a gradual loss of the neural connectivity required for complex thought and memory retrieval. A typical lunch at a restaurant often involves foods cooked in these industrial oils, from salad dressings to seared proteins. Even dishes that appear healthy on the surface can be significant sources of oxidized omega-6 fatty acids if the kitchen relies on cheap vegetable oils for preparation. The individual consumes these meals assuming they're making a balanced choice, unaware that the invisible ingredients are setting off an inflammatory cascade. Over time, the accumulation of these pro-inflammatory fats shifts the balance away from the protective omega-3 fatty acids that are critical for resolving inflammation. This imbalance keeps the brain in a state of low-grade chronic alert, diverting energy away from cognitive processes and toward immune defense. It is crucial to note that omega-6 fatty acids are not inherently evil. They are essential nutrients required for certain physiological functions. The issue is the overwhelming quantity and the processed state in which they are consumed in the modern diet. Historically, the ratio of omega-6 to omega-3 in the human diet was roughly 1-to-1, but today it can be as high as 20 to 1. This skew creates a biological environment that favors inflammation and tissue damage. The body cannot manufacture these essential fats and must source them from the diet, meaning the brain is literally built from the food the individual eats. If the construction materials are defective, the resulting structure will be compromised. Replacing these industrial oils with stable, healthy fats like olive oil, avocado oil, and butter changes the trajectory of brain aging. These fats are more resistant to oxidation and provide the raw materials needed to build robust, flexible cell membranes. This simple swap is often the most effective intervention for reducing systemic inflammation. When the neuronal membranes are fluid and healthy, neurotransmitters can bind to receptors with ease, and electrical signals propagate rapidly along the axons. This efficiency is perceived subjectively as mental clarity and quick thinking. It is a restoration of the brain's natural operational state. There is a reflective point to consider regarding how deeply these ingredients have permeated the food supply. It requires vigilance to identify them, as they are often marketed as heart-healthy alternatives. The shift requires a conscious effort to read labels and ask questions about food preparation, which can feel burdensome initially. However, the payoff is a brain that is resilient against stress and aging. The protection of the myelin sheath, the insulating layer around nerves that ensures fast signal transmission, also depends on the availability of quality lipids. Without the proper building blocks, myelin deteriorates, leading to the cognitive slowing often mistakenly attributed to normal aging. The reduction of seed oils also supports the health of the mitochondria, the power plants within each cell. Mitochondria have their own double membranes that are highly susceptible to oxidative damage. When these membranes are compromised by unstable fats, energy production efficiency drops, and the cell produces more free radicals, creating a vicious cycle of damage. Protecting the mitochondria is synonymous with protecting the life of the neuron. By curating the lipid intake, the individual ensures that the brain's energy infrastructure remains robust. The brain possesses a remarkable capacity for repair when the inflammatory assault is halted. The microglia can return to their surveillance state, and the blood-brain barrier can tighten its junctions, preventing toxins from entering the neural space. This healing process begins shortly after the dietary insult is removed. The clarity that follows is not magic. It is simply the biology functioning as designed, free from the burden of constant inflammation. The investment in higher quality fats is an investment in the physical substrate of the mind. Am I building my brain with materials that will last or materials that will crumble? Vascular health and the dangers of processed meats. The brain is a voracious consumer of oxygen, utilizing 20% of the body supply despite representing only 2% of its mass. This immense oxygen demand means that cognitive function is inextricably linked to vascular health. Andrew Huberman emphasizes that whatever impedes blood flow fundamentally impedes brain function. Processed meats, containing high levels of nitrates, nitrites, and excessive sodium, represent a direct threat to the delicate vascular network that feeds the brain. These compounds are known to damage the endothelial lining of blood vessels, reducing their ability to dilate and constrict in response to the brain's changing energy needs. When the blood vessels stiffen and narrow, the delivery of oxygen and nutrients to deep brain structures is compromised. The biological mechanism of harm involves the conversion of nitrates and nitrites into nitrosamines, particularly when exposed to high heat or the acidic environment of the stomach. Nitrosamines are potent oxidative agents that cause cellular stress and DNA damage. In the context of the vascular system, they reduce the bioavailability of nitric oxide, a critical molecule that signals blood vessels to relax. Without sufficient nitric oxide, blood pressure rises, and the microcapillaries in the brain act like clogged pipes. The hippocampus is particularly vulnerable to this hypoperfusion or reduced blood flow. Without a steady stream of oxygenated blood, hippocampal neurons begin to shrink, directly impairing the ability to form new spatial and episodic memories. Consider the routine inclusion of bacon, sausages, deli meats, and cured hams in the daily diet. These convenient protein sources deliver a concentrated dose of vascular toxins with every serving. The individual might perceive a sandwich with processed turkey as a healthy, low-fat option, yet the preservatives within the meat are actively working against the flexibility of the arteries. Over decades, this cumulative damage leads to a stiffening of the carotid arteries and the smaller vessels within the cranial cavity. This creates a scenario where the heart must work harder to pump blood to the brain, and the brain receives less of what it needs to function optimally. This subtle strangulation of neural tissue is a primary driver of vascular dementia. It is important to acknowledge that high-quality, unprocessed meat does not carry these same risks and can be a valuable source of nutrients like B12 and iron, which are essential for nerve health. The danger lies specifically in the processing methods, curing, smoking, and adding chemical preservatives. The presence of heme, iron, and red meat can also catalyze the formation of nitrosamines in the gut, but this effect is significantly amplified in processed varieties. The distinction is between a whole food that the body is adapted to digest and a chemically altered product that triggers oxidative stress. The elimination of processed meats is a targeted strike against a specific category of toxins rather than a rejection of animal protein entirely. When the vascular system is healthy, the brain enjoys a surplus of oxygen that supports intense cognitive effort. This is why physical exercise, which improves vascular health, is so strongly correlated with memory performance. However, exercise cannot fully undo the damage inflicted by a diet that chronically injures the blood vessel walls. Removing the source of the injury allows the endothelium to heal and nitric oxide production to recover. As blood flow improves, the brain acts like a sponge, soaking up the necessary resources, and the clearance of metabolic waste products, such as beta amyloid, becomes more efficient. The brain has a cleaning system known as the glymphatic system, which works best when vascular perfusion is optimal. The impact of sodium in processed meats also plays a role in cognitive decline. While sodium is necessary for nerve conduction, the massive amounts found in cured meats disrupt the delicate electrolyte balance required for blood pressure regulation. Chronic hypertension is a well-established risk factor for cognitive decline because it physically damages the small vessel walls in the brain, leading to microbleeds and white matter lesions. These small injuries interrupt the white matter tracts that connect different brain regions, causing a slowing of processing speed. The individual may notice that it takes longer to solve problems or that multitasking becomes increasingly difficult. The transition to fresh, unprocessed protein sources is a critical step in preserving the vascular highways of the brain. Whether the choice is fresh poultry, fish, or legumes, the absence of nitrates and excessive sodium allows the cardiovascular system to operate without unnecessary stress. This vascular resilience ensures that the brain remains well oxygenated during periods of high demand. The connection between the heart and the head is literal. Protecting the vessels is protecting the mind. A brain that breathes well thinks well, and maintaining open, flexible arteries is the key to ensuring that oxygen reaches every neuron until the very end of life. Am I restricting the flow of life to my own mind? The gut-brain axis and artificial additives, the connection between the digestive system and the brain, is so profound that the gut is often referred to as the second brain. This bidirectional communication highway, the gut-brain axis, relies on the vagus nerve and biochemical signaling to regulate mood, cognition, and stress resilience. Andrew Huberman and the broader scientific community have increasingly focused on how artificial sweeteners and chemical additives disrupt this delicate ecosystem. Non-nutritive sweeteners, such as aspartame, sucralose, and saccharin, interact with the gut microbiome in ways that can be surprisingly detrimental to cognitive health. While they offer the sensory experience of sweetness without the calories, they can alter the composition of gut bacteria, promoting strains that drive systemic inflammation and metabolic dysfunction. The mechanism by which artificial additives harm the brain is often indirect but potent. Beneficial gut bacteria produce short-chain fatty acids like butyrate, which nourish the gut lining and protect the blood-brain barrier. When artificial sweeteners decimate these beneficial populations, the production of butyrate falls and the gut barrier becomes permeable. This leaky gut allows bacterial endotoxins to enter the bloodstream, triggering a systemic immune response that eventually reaches the brain. Furthermore, certain additives can act as excitotoxins, overstimulating neurons to the point of exhaustion or death. Aspartame, for instance, breaks down into compounds that can alter neurotransmitter levels, potentially disrupting the balance of dopamine and serotonin required for stable mood and memory. A scenario common in modern life involves the consumption of diet sodas and low-calorie snacks in an effort to manage weight. The individual believes they are making a responsible choice by avoiding sugar, yet they may be introducing compounds that confuse the brain's satiety, signaling and disrupt the microbiome. The sweet taste signals to the brain that calories are incoming, but when no energy arrives, a metabolic mismatch occurs. This can lead to increased cravings and a dysregulation of the brain's reward system. More critically, the alteration of the gut flora impacts the production of neurotransmitters. Roughly 90% of the body's serotonin is produced in the gut. When the microbiome is chaotic, the chemical foundation for a calm, focused mind is destabilized. There are limitations to the research, as individual responses to artificial sweeteners can vary based on genetics and existing gut health. However, the precautionary principle suggests that introducing novel chemical compounds into an ancient biological system carries inherent risks. The brain evolved to recognize sweet taste as a marker for energy-dense, safe foods like fruit. Decoupling taste from nutrition confuses the predictive coding of the brain. The additives found in highly processed foods, emulsifiers, texturizers, and colorants, further contribute to the inflammatory load. These compounds are foreign to the digestive tract and often act as irritants that keep the immune system in a state of chronic vigilance. Resolving the future hook of cognitive longevity requires a return to simplicity. By eliminating artificial additives and fostering a diverse, healthy microbiome with fermented foods and prebiotic fibers, the individual rebuilds the foundation of mental health. A healthy gut produces the precursors for neurotransmitters and dampens inflammation before it can threaten neural tissue. This restores the integrity of the gut-brain axis, allowing for clear, noiseless communication between the body and the central nervous system. The promise of age-related vitality is fulfilled not by adding more supplements, but by removing the chemical interference that disrupts the body's innate intelligence. The conclusion of this journey points to a singular, empowering truth. The brain is resilient, but requires a hospitable environment. The 4 categories of foods discussed, refined sugars, industrial seed oils, processed meats, and artificial additives, share a common trait. They are biological mismatches that drive inflammation, impair vascular function, and disrupt metabolic signaling. By systematically removing these insults, the risk of memory loss is not merely reduced. The trajectory of aging is altered. The brain retains its plasticity, its speed, and its ability to hold onto the narrative of one's life. The path to a sharp mind in the later years is paved with the choices made at the breakfast, lunch, and dinner table today. Does my need for convenience outweigh my need for clarity?